Day 17 of 90 Days of Rust, and today we tackle the topic that makes people quit: lifetimes. Here's the promise: by the end of these 5 minutes, lifetime annotations will stop looking like magic punctuation and start looking like what they actually are: contracts. The borrow checker is already doing this reasoning for you. Lifetimes just let you write it down. Let's start by making the compiler angry. Watch this. I write a function that returns a reference to a string created inside it, fn make str, let s equals string of from \hi\s. Cargo build, and boom, missing lifetime specifier, and returns a reference to data owned by the current function. The compiler is refusing because s gets dropped when make returns. That reference would point at freed memory. In C, this compiles. It runs. And then it crashes in production at 2 a.m. So the compiler refuses, and it wants a lifetime. But here's the mental shift: a lifetime is not a duration. You are not telling Rust how long something lives. You're naming a relationship between borrows. The syntax a tick a is just a label. When I write fn first a, x, str, I'm saying, the reference coming out is tied to the reference going in. Same label, same origin. The output can't outlive the input. That's the entire contract. Now you might think, if I have to annotate every function, this is exhausting. You don't. Rust has lifetime elision. For a function with one reference input, the compiler assumes the output borrows from that input. So fn trim str needs 0 annotations. Elision fills in the a for you. This is why you've written borrowing functions for 16 days without touching a tick mark. Elision handles the obvious case. Annotations only show up when the relationship is ambiguous. And ambiguity arrives the moment you have 2 reference inputs. Picture a grep helper, fn longest underscore match a haystack, str, patterns, str. The output is a slice of haystack, never of patterns. So I tie the output lifetime to haystack alone. If I'd labeled both inputs a, I'd be overpromising, telling callers the result might borrow from patterns too, which shrinks how long they can use it. The annotation is precision. You're telling the truth about where the data comes from. This pays off hardest in zero-copy parsing. A log line parser, fn parse underscore fields a, line, str, splits a record into timestamp, level, and message, returning 3 slices into the original line. No allocation. No string of from. The A says all 3 outputs live exactly as long as line does. The owned version that clones into 3 string s is simpler to write, but in a hot logging path it allocates on every line. Lifetimes are how Rust gives you the speed of pointers with the safety of ownership. Now the piece everyone trips on: structs that hold references. Say I build a CLI config view borrowing from the raw args, struct config-ref a, name, str, path, str. The a on the struct means an instance can't outlive the buffer it borrows from. If I parse args into a vec string, build a config-ref pointing into it, then try to return that config-ref after the vec drops, compiler stops me cold. Same guarantee as before: no reference outlives its source. This is exactly the network service bug where you cache a CR to a header, then reuse the request buffer, a use after free in C, a compile error in Rust. And the fix is always one of 2 moves. Either tie the lifetime explicitly, give the handler a req lifetime so the borrow and the buffer share a fate, or own the data with a string and stop borrowing entirely. Cloning isn't cheating, by the way. It's a valid answer when the data genuinely needs to outlive its source. Just choose it on purpose, not to silence the compiler. Day 17 done. The takeaway: lifetimes don't add restrictions, they make existing ones visible, naming the borrow relationship so it travels across function and struct boundaries. Tomorrow, day 18, we put a bounds on traits. Subscribe for day 18.